Okay. Rochelle will start there by you. That's correct. You got it right. Good job. Right, 1.2, Nikita. Well done. Got it right. Number 1.3, Rietsang. Okay, let's just first look at the distributive law. That negative has to multiply in with each term. Okay, so you see P is positive. So if a negative is going to be multiplied with it, it's going to be minus P. Do you agree with that? Okay, and then I agree with you, negative times negative will be plus 2. But now, Rietsang, you must remember, these are expressions, right? So therefore, when you want to add or subtract expressions, the terms variables and exponents must be the same. So this is a term that has a variable of P. This term has no variable. So can you see these two terms are not like terms. So therefore you cannot add them. And if you cannot add them, then that's the end of the sum. Okay. Remember with expressions, it can be a sum as an answer. Okay, you don't have to get a single answer. We got this one right, minus P plus 2. Tsolo Felu. 24 m to the power of 6, s to the power of 6 and p. If you wanted to, you can shuffle it alphabetically. M to the power of 6p and s to the power of 6, that will be fine as well. Who got it right? What did I write here? 24. Oh, 36, excuse. Okay, next up, 1.5. Okay, this is not a distributive law. Look here, all of you. Mosa. This is not a distributive law. Who can tell me why it's not distributive law? I'm referring to distributive law. Distributive law says you take the number outside, you multiply it with each term on the inside. Why is this not regarded as a distributive law? Okay, I want you to look carefully now. This is a common mistake that we make. Distributive law says you take what's outside of the bracket, you multiply it with each term inside of the bracket. Am I correct? Okay. What separates the term? So how many terms are in here? 1. Okay. So if I multiply t squared in, I should only multiply it in once. Okay. I shouldn't multiply it with each term because there is only one term. Right. The other thing that I want to remind you of is that if you can do what's inside of the brackets, you do what's inside of the brackets. Okay? So we're going to do it together. Right. What will the answer of what's inside of the bracket be? T times t to the power of 4. T to the power of 5. Okay? And what is t squared times t to the power of 5? What do you do with exponents when you do multiplication? Plus, so what is 2 plus 5? And therefore the answer will be t to the power of 7. Okay, you can add a note there for you or for yourself. If the number is on the outside, you multiply it with each term. Must have a plus or a minus. Okay, and then the other mistake that we see is if you've got raising of a power, for example, you can only do that when there is one term. Okay, so if there's something with a plus in between, you cannot raise the power. Everyone done? Okay. This is a nice question. I like this one at 1.6. Okay, so Siyabonga, what did you do first? Before I ask you, or before you tell me, all of you, can you see this one has got two terms? Right. So therefore you would multiply twice. If there were three terms, you would multiply 3 times. But like the previous one had one term. Therefore you only multiplied once. Just back to this one. If you were to do it using distributive law, you would say t to the power of 2 times t, which will give you t to the power of 3 times t to the power of 4. That's what I mean when I say you only multiplied once. You only multiplied with one of the things. And then you can multiply the two things, t to the power of 7. Do you all understand? Okay, on to 1.6. Yeah? Okay, I'm so glad you say that. Because if you look at that thing, Botmas, you did subtraction first, no? Okay. Where does subtraction, which letter represents subtraction? And where is that in the word? Okay, so why do you do it first? Okay, but you subtracted first. Should you subtract first? You should subtract last. I've said this many times in class. You do not do anything while there are still brackets in your sum. You do nothing unless you've gotten rid of the brackets. Do you hear me? How do you get rid of the brackets? You either do the calculation inside of the bracket. If that's not possible, you use the distributive law. That's your step 1 when you've got brackets. And if you can't do either of those two, then you can't finish the sum. You cannot do the sum. Siyabonga, do you see there is a distributive law? What is being multiplied with the bracket? Negative 2c is being multiplied with the bracket. Now that's if I want to use the distributive law, and I can also check if I can add these two terms. Can I add 4b and 2? No, so that means I have to do the distributive law. Right, so you can do it now. You're going to multiply a negative and the number and the variable. So what's a negative times a positive? What is 2 times 4? What is c times b? BC. Okay. What is a negative times a positive? And 2 times 2? And c times, there's no other variable? And then it looks like that. Do you understand that, grade 8? Okay. See, how do you think the sum is done now? There are no more brackets, ne? There are no exponents. There are no roots. There's no multiplication. There's no addition. So there's only subtraction left in that sum. Now you can do subtraction. What can you subtract? 5c minus 4c. And what is 5c minus 4c? 1c. And then you get your answer. C or 1c minus 8bc. Who got this one right? Good. So you all look carefully at this one. You don't start a sum while there are still brackets in it. 1.7. Okay, I agree with your variables, but why do you say the cube root of 125 is 5 to the power of 3? Do you know what 5 to the power of 3 is? How much is 5 to the power of 3? How much is it? Those are ones that you must know, ne? 5 to the power of 3 is 125. So you are saying, if you say this answer is 5 to the power of 3, you are saying the number that multiplies with itself 3 times to get 125 is 5 to the power of 3. You're saying it is 125. So you're saying 125 times 125 times 125 is 125. Do you hear what you're saying, what your answer means? Okay? So I understand the 5 to the power of 3. It's true, 5 times 5 times 5 is 125. But a cube root asks, which number multiplies with itself 3 times to give me 125? Now, which number would that be? You were close with 5 to the power of 3. Niaman, come on. This thing alone is actually also one that you must know. The cube root of 125 is 5. Okay? Do you understand that? So it must be a single number, not the one that has been multiplied. Just the number itself, the base. Okay? So therefore it will be 5, and then this you did perfectly right. 12 divide by 3 gives me 4. 10 divide by 3 gives me 10. 3 divide by 3 gives me 1. Do you understand? Okay. So if I ask you what is the cube root of 8, it's not going to be 2 to the power of 3. It will be 2. Just the base is your answer. Okay. Who got this one right? Good. 1.8? To what? Y8. Y to the power of 8. Ayanda? Negative 20 x to the power of 2y. Kailan? Negative 4a c to the power of 3. 1.11 now, lady? N, just N. 1 N or just N is fine. Because the 6 will cancel out, the K will cancel out, the L will cancel out, the M will cancel out. They will all be 6 to the power of 0, which is 1. K to the power of 0, which is 1. L to the power of 0, which is 1. M to the power of 0, which is 1. N to the power of 1, which is N. And 1 times 1 times 1 times 1, how many times will always be 1? You got it right, just N? Good. Okay, 1.12. Katleo, I already split the fractions. I hope you did that as well. What did you do? So you added everything there at the top or what? Okay, when can you add terms? When can you add those 3? Who can help her? Naleria? I'm asking, when can you add the terms? No. The variables and? Sia, the variables and? The variables and the exponent. So Katleo, can you see that's x5, y4, z. X squared, y to the power of 3, z to the power of 2. X, y, z. Can you see the exponents are not the same at all? So can you add them? No. Who knows how to do the sum? Naleria? Okay. So let's look at what Naleria did. We did many of these sums in the second term, Katleo. All you had to do was page back. That's what we expect of you now. Page back so that you can start studying. When you've got that single denominator there, you have to split this sum into 3 separate fractions. Each one of them will have a denominator of minus 3xyz. And that's how we get it to look like that. Because if you think back to fractions, when we did fractions in the first term, we said we'll find a common denominator and then write it as 1. So we're actually doing fractions backwards. Okay. And then you divide these two, get the answer. Then you divide these two, get the answer. Then you divide these two, get the answer. These variables and exponents are still not the same. So you can still not take it any further to add and subtract any further. That is your answer. A trinomial. 3 terms in your answer. Who got it right? Good. Can I page? Curapetse, did you do nothing or did you do 1.13? You did this one. Okay? Okay, stop there. Number 1. Page back to that note I had you write down now with the brackets. We said if there's a number on the outside of the bracket, you multiply it in with each term once. If there's an exponent on the outside, you can only raise the power if there's one term inside of the brackets. Do you see that, Kiropetse? Okay. Now back to this sum. How many terms are inside of this bracket? 2 terms. So can you raise the power when there are 2 terms? No. Only when there's 1 term. Okay? If you can do what's inside of the brackets, you still do that first. The extras that we've learned is only when we have a situation where you cannot do what's inside of the brackets. Okay, that's my number 1 problem. My second problem, if you raise the power 2 to the power of 10 to the power of 3, ne? If you raise that power, you have to multiply all of the exponents with the one on the outside. So you said it's 2x to the power of 30, am I right? Whereas it should be 2 to the power of 3, x to the power of 30. That exponent goes to each exponent on the inside. Do you remember that? Okay. So even if this, you shouldn't have raised the power here, but if it was a raising of a power, you must raise each and every exponent inside. Do you understand? Okay, so now you're going to do it correct. Can you do what the sum is inside of the bracket, Kiurapetse? We can, because it's x to the power of 10, x to the power of 10. So it's got the same variable and the same exponent. And when they are the same, we only add and subtract the number in front. Okay, so what's the answer going to be of what's inside of the bracket? No, listen to what I'm saying. We're doing what's inside of the bracket. So the sum I want you to do is 2x to the power of 10 minus x to the power of 10. Do these two terms have the same variable? What's wrong with you? Do they have the same variable? Do they have the same exponent? Which means I can add and subtract them. Right. Once you know you can add and subtract it, you only add the numbers in front. In other words, the coefficients. What's this one's coefficient? What's this one's coefficient? Okay, so what is 2 minus 1? It's 1. And then after you've done the subtraction, the variables and the exponents must stay the same. Does this sound familiar, Kiurapetse? So therefore, the answer will just be 1x to the power of 10 or x to the power of 10. And now we're not done yet. Now we still have to raise the power. Can you raise the power now? Yes or no? Because it's one term inside. Now I can raise the power. Right? So what's the final answer going to be? Where do you get 3? That's an exponent, Kiurapetse. Exponents multiply with exponents. So even if you take the 1x to the power of 10, that exponent is most 1. Now 1 times 3 is 3. So what is 1 times 1 times 1? Times 1 times 1 times 1 a million times. 1. It will always be 1. Okay? So that cannot become a 3 at all. You don't multiply the numbers with exponents or add or anything. A normal number can only calculate with a normal number. An exponent can only calculate with an exponent. Would you like to have a conversation with the rest of the class? Because when I talk to you, you're looking all around. So, number 1, you didn't finish your homework. Number 2, you're not getting it right. And when I explain it to you, you decide you want to look around. If it's not necessary for me to explain it to you, then you let me know. The final answer is x to the power of 30. You got it right. .14, Bukang. Now give me this 1.14. Not 1.15. You skipped it, okay? Now lady, I'm going to skip you because you've given an answer. I'm going to go on to Mbali, okay? And then you come back for 1.15. Mbali? You can just read me the next line. Good. So what she did there, she applied the distributive law. And we can do it here twice because there are 2 terms inside of the brackets. Okay. Mbali, and then? What? What did you say? Did you just shuffle it? And that was your final answer? What's your final answer? Okay, so you decided that all of these terms are the same. I can just add and subtract them together. Can you add terms that aren't the same, Mbali? Are these terms, all of them, the same? What's different between the terms? You are saying these terms are not the same. Why do you say they're not the same? Mbali, you are kind of wasting our time now when I ask you a question and you don't answer. 4 doesn't have a W. Is that what you said? And 8 doesn't have a W. That's correct. But the other two, they have W's. So do you see your mistake? You cannot add 4 and 2W and 4W because they're not the same. Okay, what's 4 plus 8 then? And what's your final answer? Okay, we are almost there. 4 plus 8 is 12, but this is minus 2 plus 4. Mbali, what's minus 2 plus 4? Minus 2 plus 4. Mbali. Minus 2. See the number line in your mind. You are at minus 2. You add 4. You are at minus 2. You add 4. Dankie. 2W plus 12. Do you see? We did this just before the exams. You wrote exams about this. And this is how you guys are answering this. And you have a book with you even when you answer these questions, but you're too lazy to page back. 1.15 Pamelu. No. Bokang. Okay, let's just quickly look there. I don't know. Just look whether you wrote down the question correctly. 4x to the power of 3, y to the power of 2, z to the power of 5. Okay, so this is what it's supposed to be. Okay, so you help me with this one. What did you do with that exponent? To all of these exponents inside, ne? I can do it in this case because there's only one term, ne? Okay, so 1 times 2, now the bases will have to stay the same, ne? What is 1 times 2? 3 times 2? 2 times 2? 5 times 2? And you know you said 3 times 2 is 5 in your answer, ne? You don't add these two. When it's raising of a power, we need to remember to multiply them. Okay. And then it looks like that. But, Bokang, you gave us the final answer that's different from this one, except for the mistakes with the variables exponents. You said the answer will be 16. How did you know you have to calculate this one? It's because it's one of the ones that you must know. Okay. If this was 4 to the power of 9, you don't calculate it. You must know 4 to the power of 2, 4 to the power of 3. That's it. 1 to the power of 2, 1 to the power of 3. 2 to the power of 2, 2 to the power of 3. 3 to the power of 2, 3 to the power of 3. 4 to the power of 2, 4 to the power of 3. And then 5 to the power of 2 and 5 to the power of 3. The rest, you must just know to the power of 2. You're supposed to have this at the back of your book, ne? Okay. So you must study that. So final answer, 16x to the power of 6, y to the power of 4, z to the power of 10. Okay, number 2. Where are we now? Pamelu. They gave us this expression. What is the coefficient of x to the power of 3, Pamelu? -2. If the negative is not there, 0. I just want to ask, who got 1.15 correct? 1.15. That's easy sum, guys. You cannot be getting that wrong. And we've done so many of them. Okay, that one is -2. Got that one right? 2.1, -2. Good. How many terms does the expression have, Ayanda? 4 terms. What is the mathematical name of the term -10 in the expression? It's the constant. If -5, x equal to if x is equal to -5, calculate the value of the expression. Okay, do you know what type of sum this is? Who knows what you had to do here? What type of sum it is? What is it called? Substitution. Did you do the substitution? Okay, Calvin, so you are next. You're going to have to help us there. Substitution is when you take that expression, they give you the value of x. We have to take out the x only, everywhere where it is, and substitute it with the value given. And when we substitute, it must be in brackets. Is it necessary to put it in brackets? Yes, because you get a mark for that, because that's indicating that I'm doing substitution. Alright, Calvin, read me the substituted equation or expression.
5 brackets -5 to the power of 2, -2 brackets -5 to the power of 3, minus 10, minus 7, no, minus 10, then -7 brackets -5.
Very good. Do you all understand that? Okay, now, who said? Ayanda said there are 4 terms. Do you agree with it? Calvin? Okay. This is the first term. This is the second term. Third term. Fourth term. I want the answer of each term. Okay, so starting at the first one, which will be 5 times -5 squared. What's that going to be?
It's going to be 5 brackets positive 25, which will give me an answer of positive 125.
Okay, so it's 5 times, or -5 times -5, which is 25, times 5 is 125. Do you agree with that, everyone? Okay, and then what is the answer of the second term?
So I said -2 brackets -125. Then I said -2 times -125 and then positive 250.
Very good. So the answer of the second term is plus 250. The third term, was there anything to change in the third term? No, because it's a constant and that's what makes it a constant. It can only be -10. Klar. Okay? And then the last one?
I said -7 times -5 will give me a positive 35.
Positive 35. And then when you add and subtract these numbers, what's your final answer?
Then I said 125 plus 250 plus 275. Then I said 275 minus 10 is 365 plus 35 is 400.
400. Very good. The got it right, 400. Okay, well done. Okay, grade 8, we are going to do another revision on this. Because as you can see, you are doing silly things. And now when you do the second revision, you must get everything right. Because as I say, you've got your book with you. If you get to that big division sum, you page back, you go and see, how did I do this again? We did all of this work during the second term. Right. And then you guys remember of the test on Monday. It's on this, on the equation, solving the variable. And although it's in here as well, I'm just going to name it the substitution. Okay. The